Hello and welcome to my channel. I am Mr. Eid and I teach mathematics. This is the final video of a series that started from basic factorization to solving any equation of degree 2 or of power 2. The highest power is 2. If you haven't watched the whole series, please check out the videos before, and if you need help with other topics, please visit our channel and look at the other topics that have been uploaded. Without further ado, this is our last video. This is where we reveal the golden nugget. Let's get into it. So in the previous video, we saw how to solve something that looks like this. And we have discussed how to complete the square. I'm just going to do it very quickly. Divide here. So 8x is 8x. You divide by 2 to get rid of the 2ab. So this becomes plus 4 here. And so b is 4. So this is plus 16 minus 9 equals 0. If you cannot do it quickly, review the previous video. X squared plus 8x plus 16. This is x plus 4, the whole thing squared. Minus 16 minus 9, that's minus 25 equals 0. And here x plus 4 minus 5, x plus 4 plus 5, because a squared minus b squared equals 0. Again, I'm doing it quickly because we have studied this last time. And you get x minus 1 into x plus 9 equals 0, x equals 1, or x equals negative 9. So this is equal 0 here, and this here, or this equals 0. These are the two solutions. Now, instead of doing all of this work, because they all look the same, right? Like if I change the number here to minus 10, it's gonna have to do the same thing. If I change this here to a 7, you're gonna have to do the same thing, right? If I change this here to a 2, it's gonna have to do the same thing. So instead of doing the same hurdle all the time, okay, people sat down and say, well, if you think we've done a brilliant move so far, oh wait, you're gonna love this one. They said every equation looks like this. Every second order equation looks like this. Just some number here times x squared plus some number times x plus some number. That is the case for everyone. Now you tell me, oh look, but there's a minus here. Yeah, plus minus 10. So our number will be minus 10. Okay, it's just a general form. This is the shape of every quadratic equation. Every equation of degree 2 has this shape. So how do we solve this? Well, of course, we're not expecting when we solve this, we're not expecting when we solve this to get exact solutions or known solutions, because I don't know what A is, I don't know what B is, I don't know what C is. What you really want me to just solve this without knowing these numbers? And what I want to do is not to solve it, as in give me a solution, but to generate a model, to generate a mold that fits all of the possible solutions for every possible equation. We're going to do something completely brilliant. If you haven't seen it before, stay tuned. So we have this, and first things first here, to do completing the square, what I have to do is I have to remove this a. This a is kind of bothering me here, because I want a square, and this a is not squared. I mean, it could be 4 or 9 or 16, but it could be 15 as well. It could be 7. So I gotta get rid of it. And the way I get rid of it, well, you divide by a. So I'm gonna divide by a here, I'm gonna divide by a here, I'm gonna divide by a here. Of course, when I divide by a on the right hand side, nothing happens because 0 divided by anything is 0. So here you get a divided by a, which is 1. X squared, stop writing this, please, plus b divided by a. X, don't feel afraid of it, just b divided by a, plus c divided some number, equals 0. So this is step 1 of figuring out the quadratic formula. So I'm gonna remove the a. Next, I'm gonna complete the square here. Okay. This is how I'm gonna do it. I'm gonna keep x squared. I'm gonna keep b over a x. But then I'm gonna assume that this is 2ab here. So this is 2 times the first times the second. Well, we know that the first number is an x here. So this x, sorry, I should not remove it. This x is this x. And we are stuck with 2 times something and then b over a. Can b over a be written as 2 times something? Is the question. And we don't know, because b over a, I don't know b, I don't know a. What I know for sure is, when I multiply and divide by the same number, I haven't done anything. 2 times a billion divided by a billion, that's still 2. I don't need to calculate 2, and then I get the answer. Just opposite operations, they cancel out. And so what's b over a? Well, if I really want to multiply by 2 here, I gotta repeat the same trick as we did before with the addition and multiplication to cancel out our cheating. I'm gonna divide by 2. So if I want a 2 to be forced, I'm gonna divide by 2 and I'm gonna write b over a here. 2 times b over a divided by 2 gives you b over a. This is absolutely correct. Don't feel afraid of this, by the way. It will look very easy when we simplify. I just want you to check that this is the box here. 2 times this box gives you this. I want you to be absolutely convinced of this. And if this is the case, well, all what's left of this is to say that, well, b divided by a divided by 2 is nothing but this. If you find this difficult, watch our other series on fractions, which will be uploaded soon. So b over 2a is what we're looking for. So let's remove all of this from here. So this box here, we figured it out. This is let me write it differently. 2 times b over 2a. These 2's in my intention cancel out, and then you get b over a again. Okay. And then x plus c over a equals 0. And now I can complete the square. Now I have the beginning. I have x squared plus 2 times b over 2a x. This guy here is my other term, a squared plus 2ab plus b squared, right? So this guy is my other my other term in the remarkable identity. So I'm gonna add that square here, add this, and then remove it just like we usually do. Don't be afraid. Don't be afraid. It looks complicated, but it isn't. If you know what you're doing, it should follow smoothly. I just added the square of this, which we used to call b before. So now the a and the b's are gonna be confused, but don't be confused. So this is a squared plus 2ab. Well, I should write actually ba here plus b squared. They are different b's. Well, let me write it differently. P squared plus 2qp plus q squared. It's the same one. I just removed the a and b for the confusion. So here, if you look at this guy here, this is the square. That's what I mean. Okay, it's just like the 6 and the 9 that we did here before, or the 2 and the 3, or the whatever. When you add and remove this, this is exactly what this is. It's just that the numbers, we don't know them. Okay. Now, x squared plus this gives us a square. That was the whole point. What square is this? Well, this is x plus, this is the second term, b over 2a squared minus b over 2a, the whole thing squared, plus c over a equals 0. We're getting there. Hang in there. Okay, so these 3 terms, they group up, they make this, and then these 2 here, they make 0. Now, this I'm not gonna touch again, because I worked very hard to get this. However, here, I have work to do. What's b over 2a, the whole thing squared? Well, it's a fraction, so you gotta raise the numerator and the denominator to the powers. So this is minus b squared over 4a squared plus c over a equals 0. And again, here we have work to do. To do this addition, we need common denominator. What is the common denominator, I hear you ask? And I need to multiply here by something to make it 4a squared. What is that something? That something I need to multiply by an a for a to be a squared. It needs to have an a. But I need a 4 as well, so I need 4a instead of a. And what does this give? This is x plus b over 2a, the whole thing squared, minus b squared over 4a squared, plus 4ac over 4a squared. And those of you who know this formula or who remember it, they can already tell that, this looks familiar. This is where it comes from. It's just the same trick. We've been using the same trick of completing the square all over and all over again with our whenever we do our discriminant formula, or the quadratic formula people call it as well. And so here, how do I continue? Well, since I have the same denominator, I can add the numerators together. So you get x plus b over 2a, the whole thing squared here. And I'm going to write the same fraction for everything. So I'm going to put a plus outside. This is plus minus, but you don't see the plus. We don't write it. So plus, and then you have minus b squared, copied from here from the top, plus 4ac here, divided by 4a squared equals 0. Okay. This doesn't really look nice. What do I do? I have x plus b over 2a here squared. And the next step, if you remember, is a minus b into a plus b is equal to a squared minus b squared. This is the next step, the next trick that we will use, and the completing the square bit. However, here we have this nasty plus. And so what I'm gonna do is I'm gonna well, I cheated. Don't cheat. I'm gonna put this a minus here and then flip all the other signs. I can do that. So this is b squared minus 4ac here over 4a squared. Why can I get away with this? Well, because this minus applies to everything here. So you get minus times, there's a plus here, so plus b squared, you get minus times plus, it's minus. And then you get this minus times minus here, which gives you a plus. So I have not cheated, actually. I have done a very legal move by replacing the plus here with a minus. This plus has become a minus, and all these signs have flipped. Why am I doing this? Because I need to see a minus here. I need a minus between the two. And now we can proceed. Now I have the minus, and I have the first square. But what about the second square? I have a squared here. Fantastic. What about the second square here? Well, if you don't see a square, create one, right? Just make a square. Anything, let me use another letter. Anything is this. Anything. Square of something. Squared gives you anything. Anything, literally here. Anything. Square rooted squared gives you anything. Gives you the thing itself. Anything works here. So here, this is just the square of the square root of itself. So I have x plus b over 2a. So that is my a here, or my first term here, minus the square root of this. Okay, so the square root of b squared minus 4ac over 4a squared, multiplied by, let me copy this down so that it has space, multiplied by x plus b over 2a plus the square root of plus b here, b squared minus 4ac over 2a. Well, over 4a squared actually, from here, equals 0. We're almost there, hang in there. You don't have to do this every time. We're doing this work one time because we want to pay for it once and then once and for all. So now we have almost done. We have reached the point where I have two brackets that are multiplied by each other and they give 0. Well, if that is the case, then all you need is set the first one here equals 0 or the second one equals 0, right? Very easy, very smooth. Let's do that. X plus b over 2a minus the square root of b squared minus 4ac over 4a squared is equal to 0. Or I'm just going to put them under each other to give myself space. Or x plus b over 2a plus the square root of b squared minus 4ac over 4a squared is equal to 0. Either the first one equals 0 or the second one equals 0. Now let's work with only one. And it will be similar for the other one because they look very similar. Now, again, for those of you who have seen this before, you recognize this one. You have seen it before, and you have seen this one here as well before. It just doesn't look exactly like what you've memorized. And the reason is because we still have a little bit of simplification to do. Remember that if you have the square root of a over b, well, let me pick other letters, b over q here like that. It's equal to the square root of b divided by the square root of q. Remember, keep that in mind. You can, if you have square root of a fraction, square root of the top divided by square root of the bottom. So here, if you have 4a squared here, this is a nice number. This is a square. So I'm going to make it escape the square root here. So this becomes x plus b over 2a. And then minus the square root here, b squared minus 4ac, divided by, what's the square root of 4a squared? It's just 2a. And this is very convenient because now look, we have common denominator. And what this does is, this allows me to write this. X plus, well, actually, I'm going to take everything to the other side. X equals minus b over 2a plus the square root of b squared minus 4ac over 2a. And of course, because I have the same denominator, I can write them under the same fraction. And now it looks like the thing you remembered. Let me actually put it in red. Now it looks like the thing you remember. X equals minus b plus the square root of b squared minus 4ac over 2a. Perfect. Wonderful. Brilliant, right? And then if you continue the same work on the one below, you will notice that the only difference between the top here is this minus. So you will reach the other solution, which is x equals here minus b plus, or sorry, minus b minus the square root of b squared minus 4ac. The whole thing over 2a. And this, my friends, is the quadratic formula. Sometimes people write it as minus b plus or minus the square root of b squared minus 4ac over 2a like that. Technically, you cannot write plus or minus. There's no such thing as plus or minus, but people understand what you mean. And so people have grown to accept this plus or minus business. So here it is. This is where it comes from. And I understand this is very laborious. And we don't have to do this every time because we paid only once. So this is nothing but the completing the square trick that we did here. But for an equation that looks like this, ax squared plus bx plus c, and then we continued until we've reached this point where we have the formula. Now, let's just leave you with a quick example of how to apply it. I'm sure you guys can guess. So let's say x squared. So this is example here, x squared plus 6x minus 7 is equal to 0. Okay, and well, I need to find what a, b, and c are. Now this becomes very easy. So a here is the number before x squared, that's a 1. And this is b. And c here is negative 7. Remember, they did us a very bad service in kindergarten when they told us that plus and minus are operations. They are. But the sign and the number, they go together. I cannot say, you know, this is 0, and I tell you place number 1. Well, number 1 is here, but then this is another one. This is -1 and this is +1. They cannot be the same thing, and you can't just write 1 anywhere. It has to be +1, +2, -1, -2, -5, -7.3. That's how numbers work. They have a sign next to them. And so when we learned, oh, 2 plus what? 2 plus 3. You know, oh, as if the 2 exists alone. Well, yes, of course, because they didn't want to complicate it to us when they taught us in kindergarten. But these things are the way they are. You know, there's a +2 and there's a -2. There's no just 2. Okay. So for this reason, please be careful. C is -7 here, not only 7. And B is +6, not only 6. Okay. Now, how do I use the formula? Well, I say x is equal minus b. What's b? B is 6, so that's -6, plus the square root of b squared, that's 36, minus 4 into 1, which is a, and then -7 over 2a here, 2 times 1. And if you're lazy, you can pop it on the calculator. If you're not, you can follow me as I do this very quickly. -6 plus, well, let me cheat as well and say plus or minus so that, you know, we save time. Square root of 36. 4 times 7 is 28. Minus times minus is plus over 2. This is -6 plus square root of 36 plus 28. 36 that is 64 divided by 2. Now, what is the square root of 64? Remember, we're doing plus or minus here. What is the square root of 64? It is just 8. So this is -6 plus or minus 8 divided by 2. This is -6. And here you have to split them, I guess. -6 plus 8 divided by 2. This gives you plus 2 divided by 2. X equals 1. That is one solution. And then here you get -6 minus 8 divided by 2. X equals -14 divided by 2 -7. So it becomes a lot easier, you know, if you compare this work, especially that you can pop it on the calculator and give you the answer immediately, to the work we've done over here, right? Like this looks like a way, this is very expensive here. And you can at home do this equation and make sure that we get the same answers. You can use the quadratic formula to solve all those other equations now. Which concludes our video. Thank you very much. Please like and share the channel with anyone who has an exam or anyone interested in learning about mathematics. Please join our Discord. People are sharing memes there, mostly about me, and they are asking questions when they have exams, when they have hard homework, etc. It's a nice community that we have. You can also join us live on Twitch when we do the streams and ask your questions live. All the links are below in the description box. Thank you so very much, and see you in the next video. Take care. Bye-bye.